All right, so a very good evening, ladies and gentlemen, and a very warm welcome back to the Grand Salon once again. Lovely to see so many of you here. Now, this next gentleman I would like to introduce to you. I just heard him mention that he has spent the majority of the day up at the Volcano, but luckily that was today and not back in 2021. Ladies and gentlemen, please welcome Professor Valentin Troll.
Thank you so much. Thank you, Robert, for the lovely introduction. And yes, you're right. I had a day up the Volcano today, and I really enjoyed it. And I revisit some of the sites of the 2021 eruption, seeing how things have developed. The volcano is pretty quiet today, but it still steams away a little bit, so it's not entirely cool yet. But let's talk a little bit about the 2021 eruption. A few words at the very beginning about the background on the archipelago, just to summarize things we said before. We have a sequence of 7 major islands, and the oldest islands are in the eastern part. They are eroded, they're rather flat. Then the tall islands in the middle, they have a pretty long eruption history, but they're not amongst the oldest, they're of middle age. And then we have the very young islands in the west, El Hierro and La Palma. They are just growing very strong. They're juvenile islands, and they're marked by frequent volcanic eruptions. The African plate is believed to move with about 2 centimeters a year, and it's rotating slightly, pushing into Europe, creating the Alps there. And the plate motion causes the islands not to just build up amongst each other, but actually form a chain, because it's moving ever so slightly every year with this small quantity of about 2 centimeters. Well, sometimes it helps, actually. Maybe I should point this out. 2 centimeters a year is about the speed with which your fingernails grow. So that's about the speed of the plate motion. But over millions of years, that makes the distance between the islands. So this is the idea, and there's a little video. Let's see if I can get this going. Yes. So here's the idea. We have an anomaly in the mantle. It's pushing up and it's melting. It's producing magma some 100 kilometers below the surface. The plate is moving at this rate of about 2 centimeters a year, and it's creating islands this way that are moved away from the actual hotspot, from the center of magmatic activity. And the current center of magmatic activity sits pretty much under the island of La Palma. This is exactly where we are right now. So, but I assure you, as I said, I checked the volcano for you. It's pretty quiet today, so I don't think we have any surprises to expect tonight. I'm very confident, in fact. And I should point out, much of the island is actually very safe. The entire northern part of the island is free of active volcanism. It's only the southern part, the ridge, the Cumbre Vieja, that is producing eruptions. This history of island growth eventually moved further and further to the south, and we actually have submarine volcanoes off the southern tip of the island as well, and presumably they will emerge at some point, and the island will grow yet further to the south, making it even longer. So the areas on the western side of the volcano, they are densely populated, and so are some parts on the eastern side. And we're coming back to this in a little while. There's 2 population centers, effectively, and I should point this out. So this is one here, round about Santa Cruz, the capital. This is actually Calderita, the little hole in the ground here, and we are actually lying just in front of that little volcano here. But again, it's calm today. It hasn't erupted for 1 million years. So, and this is the other population, densely populated area. This is Los Llanos on the western side. And we'll come back to Los Llanos, because this is actually not in the best spot when it comes to recent volcanic activity. More than 50% of the volcanic eruptions, historical volcanic eruptions in the Canary Islands, have occurred on this ridge, this southern ridge of La Palma, the Cumbre Vieja. All the other eruptions are more widely dispersed, and this makes this the most volcanically active part of the entire archipelago. So, and here we have a little map, a simplified map. And this is the ridge, and you can just about see in gray these little pock marks, and this is all volcanic craters. And in orange here on the map, that's the eruptions of the historical period, starting in this case 1646 and then 1667. Then there was an eruption 1712, and afterwards a longer break, then followed by an eruption in 1949, then 1971, and now the latest being 2021. The images here, they go back, the drawing there is an oil drawing, it's an oil painting going back to the 1676 eruption, sorry, 1667 eruption. And then the black and white photo is from 1949, and the other two images at the bottom, they're actually from the 1971 eruption. So, realizing that these eruptions are so infrequent, and I was born in 1971, so the eruption 3 years ago was my eruption. So it was the once-in-a-lifetime opportunity to actually see a proper Canary eruption with the right background, with the right experience, and the right resource level behind. So I set out when the eruption started to go there, and you could see the eruption already from the air. There, out of my window plane, I could see the eruption piercing through the clouds, and as soon as you arrive on the island, it says, oh, there's a volcanic eruption, you shouldn't really go there, stay away, and I had exactly the opposite in mind. So eventually, with all the permission and all the paperwork completed, I went to the zone of exclusion, the no passar zone, and that's exactly where you should not go, and that's the limit of the 2-kilometer limit from the volcanic crater, and not even scientists were really particularly welcome there. So we went in there, and I went there today. Today there's a little booth there, and there you can actually get volcano leaflets. So they're now converting this to a volcano visitor site. At the time, it was the entrance to the exclusion zone. And here are a few words about this eruption. It was known to scientists for quite some time, years before. There was earthquakes already in 2017, so scientists knew something was happening there. In 2021, in mid-September, suddenly these earthquake swarms intensified, and they migrated through the crust. They migrated upwards, and that's not a good sign usually. That implies something is moving through the crust, and on a volcanic island, that is usually magma. So eventually the ground was starting to deform, the ground was swelling up as well, and you can see that in these interferograms. I showed some the other day. So here's one of these interferograms. There are these fringes in the circle there. They tell you about ground swelling up, it's deforming, and it allows to even predict where the eruption center might be, and predictions allowed to pinpoint the eruption center pretty closely. But it took some time, and eventually the alert was given for evacuation. Let me bring you back here. So, and the eruption began on the 19th of September at 2 o'clock in the afternoon. And we started off with an impressive gas plume of up to 3 kilometers in height along an open fissure of 500 meters where lava was spewing out. So, the initial seismic patterns, that means the earthquake patterns, they told us something profound, and that is that there seems to be 2 levels under the volcano. There's one level at about 10-kilometer depth, and this is time here, going on the x-axis, on the horizontal axis. And here we have a second level much deeper at 30 kilometers depth. And indeed, it allowed us to understand that the volcano had not just one, but 2 magma reservoirs sitting underneath it. And that was a bit of an unusual situation. It took us a while to understand that this brings certain peculiarities of volcano behavior. I'll come back to this a little later. So, and I went to this place today, and here it's a Google Earth image before the eruption, and you can just about see the White House here. This White House there is exactly this White House here now. And well, on the left there was no volcano, and on the right you see the volcano. And the volcano grew immensely fast with an enormous rapidity. And there on the right-hand side is Dia Uno, the first day, and then 87 days later you see this vast volcanic edifice that has grown there 350 meters in size. I went to the next place as well, and I have very mixed feelings about it. As a person, I find it shocking. As a volcanologist, I find it strangely exciting. You have to forgive me. But this is part of the eruption sequence from December 5th of 2021, where a lava flow hit the outskirts of Las Manchas. And these houses were actually in a little valley, in a former river valley, I presume, and the lava went in there and, of course, covered them almost entirely. So the lavas, they were spectacular. The footage went around the world. There was lava rivers running down the hillside. They reached speeds of about 30 kilometers per hour, which is, you know, a very fast moped, but not a lot faster. But still, as lava comes, it's very impressive. And of course, it left us with these wonderful night visions of lava coming down the hillside. And when lava runs down steep slopes, it forms these spectacular rivers. On flat ground, it usually forms fans. It fans out. And, well, this is very bad for the population, but it looks amazing at night. So here's one of the situations where you have lava hitting a flat bit, and then it really flattens out and covers a wide area. So, and this is impressions from the lavas, and I went to these places again today. The one in the lower left is the cemetery in Las Manchas, which was covered with lava. And here, various other impressions of lava rivers swallowing up houses effectively. So, and we measured eruption temperatures of 1140 degrees C. So this is really hot and very runny lava when it's emitted. And there was a total emitted lava volume of 188 million cubic meters. This is about 0.18 cubic kilometers. Let me put that in perspective for you. The entire emitted material of the Mount St. Helens eruption 1980 was 0.9 cubic kilometers. So this is actually a very, very small eruption. But it did a lot of damage because it just happened to be in a very populated area. Let's talk a little bit more about lava. It's very fascinating, personally, I find. So here's a lava flow, an AA lava flow that has come down from the Tajo Gaite volcano, as it's now known, the La Palma volcano in 21. And here's a little video. So I'll bring you very close to this lava flow. And my knees were shaking when I filmed this. So let's see how you feel when I kind of share that footage with you. So this is a wall that comes towards you, and there is nothing you can do. It's literally unstoppable. So, and you can walk away. It's not super fast, but anything that is immobile will, of course, be affected. The electricity pole there was caught about 5 minutes after that video. So, and the lava field that then started to grow in 2021 from the volcano up in the hills, it really started to spread more and more widely in the valley as soon as it reached flat ground. And this is an image from October 21 from a little hill that was already there prior to the eruption. And this is the same spot taken in December 21. So you can actually get a feel for how the lava covered the entire area here, in this case, south of La Laguna village. So, and when you go on top of the lava, that's how it looks. It's a rubble field. It's really nothing you can do with it unless you want to use it for building stones. And the Spanish, they term these fresh lava fields mal país, bad lands, because there's nothing you can literally do with it. And they're very hard to overcome. Scientifically, however, I should stress it's really exciting again. So here I feel torn all the time between, oh my God, and wow. And here we have the satellite image. The European Space Agency has a satellite system. It's called Copernicus. and it started to actually record in these time intervals how the lava field evolved. So we actually have an amazing record of how this lava field grew, and I have rock samples from all the different weeks, so I can actually link how the lava field grew with the chemistry of the lava, and this is really exciting work from a scientific point of view. But looking at it more from an understanding point of view, here in red we have the initial lava flow as it came out early in the eruption, and in orange, or whatever that is, beige, there we have the entire lava field, how it actually unfolded by the end of the eruption 3 months later. Now, there was big discussions at the time. Many people said they were surprised by the volcano. Other people said, but you live on a volcanic island. It's not that inconceivable that there may be a volcanic eruption. And then people said, yeah, but I've never seen a volcanic eruption. And then other people say, yeah, but there is the old lavas from 1949, 1585, 1712, etc., etc. And the crest has a big hiking trail. It's called Ruta de los Volcanes, the route of the volcanoes. So somehow this is a bit of a dilemma. People that live here, they feel the volcano is very good for tourism, but there was maybe a misconception about the dangers of volcanoes, particularly since the 1971 eruption was at the very southern tip where no people were living. So there was somehow a distorted view, and when you look at this here, this is the lava field as it unfolded, and it traveled right into a very densely populated area. The previous lava flows, the historical ones, were further south along the steep kind of cliffs. Not so many people live there, but this one was particularly bad because it was flowing right into a populated area. So much so that it cut off several important traffic lines, and it even created some islands. We call them kibukas, it's a Hawaiian term, and it's basically land that is surrounding by lava, but you can't get to it because it's, well, impossible to walk over fresh lava. So here we have this area here in the lava field that was not covered with lava, and the Spanish Navy was bringing people in and out, supplying the area from the sea during the eruption. Now I've driven it today. There's a new road going through the lava field, and let's see, and it's going in the southern part here, and the southwestern part to the northwest here, and it's in the thinner part of the lava flow. The lower map here is a thickness map, and the yellow area in that map means that the thickness of volcanic deposits is over 50 meters. The red means it's only about 10 to 20 meters. So you see that the cone is, of course, really, really thick. And in many upper parts of the lava flow, there's substantial thickness, 50, 60 meters. This is why the road was built in the southern part, where there wasn't the same thickness. Because it's still hot, you're not even allowed to actually stop your car on that new road because it's too warm. You shouldn't stand there for too long. So this is how we sample lava. This is actually sampling the lava flow from December 5th at the time. And here's a few other expressions. You get very routine with lava on a 3-month deployment, working with lava. And eventually you kind of get quite relaxed about it. You separate a little lava ball and you almost start to play soccer with it, and then you cool it down and you get very comfortable. I was very surprised. And the fire brigade was watching us. They were just amused. So, and this is how these things look like when you're there at the ground, and the laser thermometer tells us here that this is 504 degrees hot. The thermometer is supposed to stop at 500 degrees, so it did realize it was hotter than it can handle. So there you then can look at the entire lava field in more detail. We have these lava deltas. This is actually when lava approaches the sea and spreads in the coastal areas. We had this in previous eruptions, and they actually form beautiful agricultural plateaus in the coastal areas. And we had the 3 new ones growing in 2021 as well. There's a bit of a debate whether it should become agricultural land or whether it should actually become a volcano park. Some people want to build hotels on it. So I don't quite know where it's going. I hope the volcano park idea does have some support. I would personally like that a lot, but we will see. Anyway, the islands are growing this way, and the young islands, La Palma and El Hierro, they're still growing. They're not very sizable, and this is the way they grow. They produce lava that spreads along the coastal areas, freezes there, and therefore creates these larger terraces. Oops. So here's a little animation of the initial lava coming down the hill from the volcano in September 2021. And then it reaches an obstacle, which is this older little volcanic cone, the La Laguna cone, and then it starts to flow around it. And once it found its way around it, you'll actually see it progresses really, really rapidly. Let's try it once more. So yeah, it comes down the hillside, and this is mapped by days. And once it reaches the obstacle, it gets a bit confused for a day, but then it moves very rapidly and forms this lava plateau, and likely also some lava tunnels in there. And the evidence for that is this image here. This is drone footage from the actual eruption, and there you see these hot and glowing bits that come down the cliffs. Well, this is lava tubes that have just surfaced, and we expect that there's quite a number of them in the lava field. Once the lava field is cool enough, we can actually have a look, but not for some years. So this is footage from 2021 and 2022, and this is right at the cliffs. You see the lava going through a banana field, and then it's cascading down, and then it forms these plateaus there. And here's another impression of the lava going over the cliff. So there's spectacular footage, and well, you see the island in the lower right. There we have these plateaus. All the green parts in the coastal area are actually lava fans or lava plateaus that formed mainly during historical eruptions. So then a few words about the ash. The ash was very intense, and this is one of the main roads that was almost entirely covered. And I went back to this place today as well, and it still looks like this. So this is a house very, very close to the volcano, and we went there several times to check on the house. Initially you could see quite a large bit, but increasingly less. And the house got severely covered, as did many, many other houses there. And I'll talk a little bit more about this peculiar house, the one very close to the volcano, but it's still actually in that state 3 years later. It was not permitted to actually uncover it. So, and a lot of ash was falling, a lot of ash was causing structural problems, it was causing problems with ventilation, and a lot of the weight is pressing down on houses. If not well built, they would collapse quite easily. The ash was actually transported pretty high up, and it was traveling all the way across the Atlantic. So there has been records of La Palma ash particles in Central America, and some of the particles were also traveling up there. In the lower right, you can see a faint map. The orange colors is where the ash was traveling to. So in southern France and southern Italy, there was also La Palma ash, maybe even a little bit further. So the ash was quite intense, and I went back to the soccer ground of Las Manchas today. It is actually green again, and this was really a joy. But back during the eruption, it was halfway covered, halfway up the goalpost with lapilli and ash, and it was kind of sad to see. So the ash is quite thick, and this was a scientific sampling profile that we took, and there you see different layers, and they come from different time horizons during the eruption. So we actually have a good record here as well, a chemical record. And if you look at these tiny little particles, they're actually very, very dangerous. And if they're super small, if they're less than 10 microns, and you inhale them, you will not ever possibly get them out of your respiratory system again. The reason for that is they have tiny little spines. And the spines come from gas bubbles that expand, like in a champagne bottle where you have CO2, where you have carbon dioxide gas bubbles, and they expand. But here, the gas expansion was more rapidly than the liquid could accommodate, and then it rips them into tiny little shreds. And that's making the spines. And once you inhale that, it's going to be with you forever. So another intriguing phenomena we observed, and later on we found out it's been observed before. We believed we were the very first ones, but that was lava balls. So we were standing quite far away, and suddenly there was, well, like cannonballs being thrown at us by the volcano gods. And we have a video, and this video went viral on Twitter and other social media. It was taken by one of my PhD students, Harry, and have a little look at this. It's like a cannonball. It's unstoppable if you're in its way. So, of course, we couldn't resist. We had to look what's inside.
Go.
Whoa. I think now you can break the tire.
Hang on. Go.
But it turns out there's no diamonds in that. So it's effectively just lava balls. That's thin layers of lava that have accumulated, and they're rolling down the hillside. And, well, I guess the initial trajectory is much steeper, but then they land on the steep slope of the cone, and then they gather speed when they come down. And we described it in a scientific magazine, and we said, look, this is very important because while you may be feeling that you're at a safe distance from the volcano, if one of those things rumbles into your village, there's a fire hazard, there's an impact hazard, and you need to be aware. Luckily, the area was, of course, evacuated during the 21 eruption. Nobody actually died from the volcano, but it was intriguing to watch this phenomenon. So then a few impressions here. The eruption at night. This was also footage that went around the world. And then during daylight, again, I went to this place today. I couldn't resist, but today it was very calm. So this is the eruption in full swing, and I should share that with you as well. So this is how it looks today on the left-hand side. And this picture is about 6 months old. And it's very similar to today. When you go up to the crater, you need a piece of paper from the local government to go up there. But when you go up to the crater, it looks like, I would almost say a lunar landscape, but there's no dead tree trunks on the moon. So I'm not quite sure how to describe it, but the image in the middle, and the top middle, that is how the crater area looks today. And this is how you view it from El Paso. It's quite a towering edifice sitting above the village. And this is when you approach the crater from above. Since it sits on a slope, you can actually walk down from the other side and you'll reach it. And that's the, well, desolate landscape in the crater area right now. And there's blue haze, and blue means sulfur. So sulfur makes a blue flame, and the blue haze is an indication that there is still a lot of sulfurous gases coming out. And there you also have that blue haze again. So, and indeed you get sulfur droplets there, and that means that the sulfur must have been several hundred degrees hot. Melting point of sulfur is 260-ish. So there we have these sulfur droplets, meaning that they were evaporated from hot vapors, and there was likely tiny little sulfur lava flows in the crater. Can you imagine what a phenomenon, I thought? But I'll bring you a little bit away from scientific things now, and I'll bring you a little bit closer to the human side of things. And here, the damage, the bill the volcano is presenting. The eruption lasted for 85 days, and It did cause an evacuation of 8,000 people. Some of them are not back to this day. We've seen several houses today that were not approved for resettling, and they're standing there, and they're a vivid reminder that some people still are, well, not home from these kind of events. More than 2,800 buildings were destroyed. Of these, about 1,300 were homes, 1,500 utility buildings. More than 1,000 hectares of plantation and farmland were destroyed, and 70 kilometers of vital road were truncated. The total loss is estimated right now at about €1 billion. So this is pretty big for the EU, and we had to, we had to release emergency funds from Brussels for the event at the time. So, and just to give you a sense of dimension, this is Montagna Dodoke, and this is before the eruption in the top right, and after the eruption, you see none of these villages really made it. They're all covered under lava. I showed this before, but now I'm putting it side by side. This is from La Laguna mountain looking towards the eruption, and within about 2 months you could see how much the lava has covered. So we have kibukas, and I passed this place today. This is a suite of houses that somehow got away. The lava was flowing around it. Unfortunately, you can't go there, so even if your house survived, you're not necessarily much more lucky than the other people. But, well, these houses could potentially be resettled at some point in the future. So this is the site at the cemetery, where just towards the end of the eruption, the lava was going through the cemetery, which was causing a lot of psychological pain to local folks at the time. So here's a few more impressions of the lava, and here we have lava coming down the hillside, and this is the AA lava type. It's very hard to stop. It's not particularly fluid, it's not particularly runny, but it comes with quite some massive force behind it, and therefore it bulldozes things down rather than flowing around things very gently. So I showed this video before, and I just think it's so spectacular. I can't resist showing it again for those of you who haven't seen it yet. So it's very instructive because it tells you how these types of lavas move. It's not that they flow around as many people expected them to do. They really bulldoze things down. And this is fundamental. While we lost this house and many others like this, looking at this footage tells us, that's how these lava monsters actually move forward. And that may allow us to think about devices. And very successfully right now, the Icelanders have built lava barriers around the town of Grindavik. And while some houses were affected, the town has so far survived. So this is important lessons that were only learned over the last few years, how to deal with situations like that. So here's just a few other impressions. A rubbly AA lava making it into a village. And suddenly when I watched this, it started to kind of bring black smoke. I was very confused for a second. And then I looked around, and there was this car that the lava caught. And we had a few of those things. You cannot go very close because obviously there may be petrol in the car. And indeed, some of these situations are quite remarkable. So here we have burned objects in the lava. And there on the top right, we even see the glass melted. And here we have a burned out car, but it's very strange because I was teaching you about the difference between AA and Pahoi Hoi lava. And if we look very carefully, I told you, you can never make Pahoi Hoi lava out of AA lava because you need to actually heat it. But here, round about the car, we have an island of Pahoi Hoi lava in a rubbly AA lava. And it was the car that reheated the lava and created a different texture. So when I tell my students, you can only make one out of the other, secretly in the back of my mind, there is an exception. So, but it's not something I share too widely, but I thought it might be of interest here. So here, lava going into a banana plantation, as I said, millions and millions of agricultural revenue is lost because of this. And I also mentioned traffic, a few more words about the traffic. The lava field was covering pretty much the entire stretch from the mountains to the coast, and therefore it truncated several vital roads at the time. And here, as you see, lava overrode. Well, something has to kind of stop, and it's the traffic that stops. So here we have lava going into La Laguna village. And actually, one of my very first encounter with the lava was in this place. And I took a video from my YouTube channel. Let me show you a real dead end. So, when I sent that footage home to my wife, she said, "What about the palm tree?" And in a way, it was wonderful in a way. So seeing all that destruction and then to think about the palm tree felt really good. But I went back there. The palm tree did not make it, I'm afraid. So, but this road here, which was covered in 2022, is now free, and I've driven it today. And this new route was built. It's a connection bit where the white bar is in the little map. It connected two roads that were previously cut off from a connection with each other. And this was built in 3 months, and it was costly, but it actually connected the road to Porto Naus with the rest of the island again, and quite a technical feat. I mentioned this earlier. We had these areas, the enclosed areas in the lava field, and the Spanish Navy supplied them. So as farmers, you could go in and out, and you could bring things or fetch things for some time. And now with the new road, it's a lot better. But this area here was cut off for quite some time. So the ash cover is, of course, very bad. And I mentioned the soccer pitch in Las Manchas. Here's various houses close to the volcano, and partly they were unearthed now, partly they're still in that state. So I passed this today, and it looks pretty clean, this little restaurant. This image just got onto the cover page of Geology Today, where we talk about the social dilemma of living on an active volcano. And good news is I passed it today, and it's very clean. So these people cleaned up. That is clean as well. That was the bus stop in Las Manchas. So another problem, of course, with so much ash is pipe systems, drainage, water supply, and that has been a real problem on the island, as has a lot of constructions that were not designed with a lot of overload. And this brings me back to that house, the house closest to the volcano. So this is an image from October 27th, where you can still see parts of that house. And this is then a little later. And eventually the house was almost entirely covered. And just towards the end of the eruption, December 8th, a vent opens up just in front of the house. And here, this one here, there was a vent with gas and lava, as if the house hadn't troubled enough. So that's why you still can't go there. It's not considered a safe area. So this is the house, and just to give you a flavor, when we were doing fieldwork in October 27th, we took shelter in the evacuation zone in that little patio area in front of the little bar, and when we came back in December, the ash had actually pushed down the roof. So this now leads me to the giant cleanup. We're moving towards the more recent events, and this is, of course, still going on. The roads are getting cleaned, and you can see this is like in a ski resort, only that this is actually volcanic ash, not snow at the sides of the road. And there, the areas are now pretty clean. There we even find sort of old-timer cars that got completely buried in ash. And if I had more time, I would show you the video of how it was pulled out. And then depending on what kind of property you have to use different types of vehicles to clean things out, from very large to very small. and the ash is then collected via, for example, little diggers like this. Oops. So, and eventually eventually your house is inspected. The inspector comes, and this is the situation there, and the inspector tells you whether your house is safe or not. Well, look at the old lady there. She had a bit of an argument with the inspector. So the inspector said it has to be checked very carefully, and the old lady said, I want back in my house. And eventually the old lady was allowed back in her house. So that's a good thing there. Now, a few words about why this was all so bad and so expensive. And one of the reasons is, well, it affected a densely populated area, as I said before, and it was a flat area. In the upper map there, in the top left, you can see the lava flows in color, and in beige to pink, the population centers, pink being the most densely populated areas. And as you can see, the red area, that's the lava flow of 2021. It hit one of the most densely populated areas. Previous eruptions, like the 1949 or 1971, were in very modestly populated areas, so that wasn't really an issue. But now we're having a bit of a problem here with these areas that have the dense population sitting on a lot of historical lavas, and likely there will be more eruptions in those areas as well. What is the answer? Well, the answer is that we need to actually educate people to deal with their volcanoes responsibly. In that context, there's a 50% probability that there will be another eruption on the Cumbre Vieja in the next 50 years. This sounds not too big, but it means any place on the entire ridge could be affected with a 50-50 chance in the next 50 years by a volcanic eruption. Would you want your house in the path of the lava? And the answer is, of course, no. So you don't want to lose your livelihood, and if the volcano comes, you want to be able to move away rapidly. And I think the only answer that scientists are now pushing for is that there will be almost mandatory insurance. In Hawaii, for example, the US government is now buying out property owners that sit in hazard zones. And if you are not selling the land, you have no right for any kind of renewal, any new infrastructure, no electricity, etc. You may be able to survive there off-grid, but you lose your kind of support there. And I think we need to think about solutions like this as well, even though the eruptions are far less frequent in the Canaries. The problems are similar to other volcanic areas, and we have large population increase here right now, and this makes the problem even more acute. Having said all this, there's a few good things as well about volcanoes, and this is actually what my next lecture will be about, the good sides of volcanoes, because everything has good and bad sides. And here we have a few new opportunities. There is, of course, new land. The island has grown quite substantially, several square kilometers. This could be used for agriculture, could be used for tourism in some form, could be a volcano park. I personally would welcome that. So then there could be even a bigger thing, a geopark. This is a UNESCO-supported arrangement that particularly prolific, geologically prolific areas get support via UNESCO, and they can make a larger park out of it. And south of La Palma could actually, I think, become a geopark. So then we talked about the ash. The ash can be useful for agriculture. It could be used as a supplement, as an aggregate in, well, construction, in, well, you can mix it with tarmac and you can actually surface the roads with it. So there is research, and so far it looks very promising that most of the ash can be used for construction. So, and then of course, well, certainly I went back to these sites and I was fascinated. So I think a lot of people will actually come and want to see the volcano, even though it's quiet right now. But I think with time, La Palma will keep its reputation to be the volcanically most active island of the Canary Islands. With that, I close, and I have one more video for you. Hopefully I'll get this to work. And I say thank you for your attention, and I hope you enjoyed that, even though it was a little bit of a gloomy thing at times. So that's it. Thank you.